Normal charge is not based on electronegativity. So it's just a method of keeping track. And uh, the car helps us determine which bears most of the charge in a charge. It also identify the charge atoms that are overall. So even if the molecule is neutral, might find the charge. In most cases, before that is in a formal charge, it actually has at least some part of that charge. So it might not be the same exact charge, but at least it's charged. And we come to know which atom is holding charge. Now here the formula is this formal charge between the number of valence electrons in the atom and the number of electrons that it owns in a Lewis formula. It owns. So like here, H, number of valence electron in H is 1. Number of non-bonding lone pair. So there's no lone, it doesn't have any lone. Half the number, these are the bonding. So half of that. So half of 2. So 1 minus 1, 0. So it has got no formal charge. That means whatever electrons it had initially, now also it has the same. There's no change. So it has got gained or lost any charge. Here, fluorine had first 7. Then it has got how many lone pairs? 2, 2, 2, 6. Half of the bonding pair, because you see, one is fluorine and one is hydrogen, so it's hardly half. So 7 minus 7 is 0. So this is, both of them don't have any formal charge. The molecule is also neutral. Both of them don't have a charge. Cn minus, this is a nucleophile. So let us look at carbon. Carbon initially had 4 electrons. So this was 4. Now, if you see this, he's got 1, 2, number of non-bonding here is 2. So 4 minus 2. What about this? Half of, there are actually 6 here. So half of 6, that means 3. So this is 3, this is 2, and it becomes 4 minus 5, which is minus 1. So carbon is having a charge of negative. So even though minus is written outside, think that carbon is having the negative minus. What about nitrogen? Nitrogen initially has 5 minus the number of lone pairs. What are the lone pairs here? 2. The lone pairs are 2. So you write 2 here. And then half of these 6. So plus 3. So 5 minus 5 is 0. So it's got no charge. So out of Cn minus, who's really holding the charge? Carbon, not nitrogen. Though it might appear that nitrogen will hold, no. So this helps us find out, you see, anywhere, like here. Out of this molecule, why doesn't this have any charge? Because this had 6 initially. How many lone pairs? 4. Two lone pairs, so 4 electrons on board. Then half of these 4, half of 4, so 2. So 6 minus 6 is 0. So this has got 0 charge. Now here, the remaining O, you know, na, there's 3 minus. So we generally want to place this minus charge on each atom. Huh? What about phosphorus? P, 5 initially. How many lone pairs? None. How many? Half of 1, 2, 3, 4. 1, 2, 4 and 4 and 10. So 5, half of 5, 0. So this doesn't have any charge. What about oxygen? This oxygen, or this oxygen. How many? It had 6 initially. Now how many lone pairs it has? 1, 2, 3, lone electrons, 6. What about half of this bonding pair? Half of 2. So that's why it's minus 6 minus 7 minus 1. That's why it has minus 1. So you can find out for any. Like here, why is N positive here? The, the total charge of this is minus 1. There are 2 minus on O and 1 plus. So effectively it's 2 minus plus 1 is minus 2. So why is N here? N has got 5. What about the lone pair? No lone pair. What about half the bond pair? So there are 2 here, 4, 2 into 8. So half of 8. So 5 minus 4. That's why it's got plus 1. So this will tell you even in those mechanisms in organic chemistry, why does oxygen have minus charge, where you can calculate by this formal charge. So always remember the total charge like is 2 minus. So it will be, there will be 2 minus, where it will be, which atom you can make out. Here there is 1. So on which one? It's on over here. You can, so what you do is this will help you make the this thing. How? I'll tell you. Look, he says for drawing the general formula for molecules, the central atom is based on the number of bonds it can form. For example, I only so it cannot be the center. Usually, the atom with the lowest subscript, that means the least, and that can form the most bond. So, like NH2O, O is the least, so it is the central atom, and it can form the most bonds. So, and if they are more than the same, if all the atoms usually form same number of bonds, the least electronegative is usually the central atom. So, arrange the atom around the central atom. Draw a square bracket around the Lewis structure, like, and write the overall charge if there is. If the ion is negatively charged, add the corresponding extra electrons to the more electronegative atom. And the extra charge should be spread out. If there is, for example, 2 charge, distribute on 2 different atoms. So he is like here, the extra electron is on the O. So try to put it there. Don't put it on uh, C, because it's the most electronegative. See, O is more electronegative. And how do you do this? So, like here, first, what you do is you put C, you put a O, O, O. Then try to satisfy the valency of O. Now, this has got 6 bonding, 6, so it needs 2. So, keep 2 here. Yeah. And then here you'll have to make a bond, obviously. So, 1 is satisfied. But what about the other? You see, this has 6. So, 1 is left. So let put 1 electron from the other, and this will get a negative charge. Similarly here, it has got 6, so 1 is left. So you bring 1 electron for stability. And then this is the structure. Similarly here, SO 4 2 minus. First, draw S, draw 4 O's. Satisfy the valency of 2. Here, because at 2 minus, it just have 1 and 1 electron will be left, and that will, so this will have minus, this will have minus, the others will have no charge, formal charge. So this way it will help you. And if the ion is positive, remove the, and if you have a positively charged, remove the electron from the less electronegative, because, and work from the terminal atoms, the terminal is a noble gas by forming the necessary. So you from the, don't from the central atom, from the terminal atoms, by adding them, add the remaining electrons bonding as lone pairs to the, always remember that the octet is not always necessary. More, if it is from period 2, it can have more than 8. And like if it's period 2, it cannot have more than 8. And if it's period 3, then it can have more than 8, because it has got d orbital. So Bacon d, this doesn't have. So here he is trying to form NH2 minus. So N is the central atom, because less in subscript and brackets, and then you have one extra charge, so it has to go to the new, and then you put the terminal H here. These are the terminal atoms, and then you make the bonds. And So this is the remaining two you can put here, the remaining valence electron to the n. This is how you